Good morning, everybody. Happy Tuesday. Hope you guys are doing well. Please chime in at any time with any questions that you have or any issues that you may have encountered while working on the homework. Minor reminder, and I'll send out an email just so everyone has this in print as well. Our first in-person lab day is coming up this Thursday. This Thursday is, checking calendar, June 9th. That will be our first in-person lab day. We will meet in Richardson room 126 at 10 a.m. for 2 labs. First one will take about 2 hours. Well, shouldn't take more than 2 hours. It could be wrapped up quicker. Then we'll pause. Everyone can take a lunch break, and then I'll spend that time setting up the second lab, and we'll get through the second one, and then we'll call it after 2 for one day. So keep that on your schedule. We'll meet in Richardson 126 at 10 a.m. this Thursday, June 9th. If for any reason you cannot make it, that is fine. Just let me know about it, and I can find a different assignment that you can do instead. So, yes. That is tomorrow. Okay. Well, there's 3 students in the class. 2 of you are currently here. Does Andrew happen to have any opinions about that? Okay. Okay. Um, yeah. In that case, it sounds like Thursday. I may have to stick with Thursday. Sorry. Okay. Well, yeah, thank you for letting me know, and feel free to, whenever information like that comes up, let me know as soon as you can so we can try to plan around it. I'm sorry that we might not be able to work anything else out this week. Okay. Well, let me know if again your schedule needs change again. If you can't come in the Thursday after all, we'll figure something out. Sorry again for the inconvenience. Um. So yes, first lab this week. We'll have our next one about 2 weeks from then. I'll reconfirm as we draw in on that. We have gotten through all the chapter 10 material, and so at this point there's been all the lecture material needed to finish all the chapter 10 assignments. So I would encourage you at this point, if you haven't done so already, to try everything on the chapter 10 homework. Make sure everything makes sense on that particular assignment. If it doesn't, please tell me. And once you're satisfied with the chapter 10 assignment, that's when you do the chapter 10 quiz. Now, if you've been working, I actually haven't been looking at the homework or students' answers yet. At this particular time, because that'll just, my brain is all over the place. Sorry. At this particular time, do you guys have any questions or issues from any of the chapter 10 assignments that you want to spend time on with this morning? Yes, one sec. I'm glad you asked about this one because the fact that it's gallons... Well, the fact that it's gallons shouldn't actually matter. I'm glad you asked, though. We'll look at it. We'll look at it together and we'll talk through it. Might do some sample math if I can. All right. So hopefully you should be able to see... this is the teacher view of the homework. But everyone's numbers should... The way that WebAssign works, just as refresher, whatever is written in red is randomized to your version. So you'll have a different number of gallons. You might have a substance other than gasoline, which will have its own coefficient of volumetric expansion. So, container is made out of steel. Steel has a coefficient of linear expansion of 1 times 10 to the negative 6th. And the canister has a volume of so-and-so gallons. Canister is filled with some amount of a liquid, and you are given the coefficient of volume expansion for that particular liquid when the temperature is 10 degrees Celsius. If the temperature rises to some other temperature, how much of the liquid will spill over the edge of the container? Okay. So, this is going to become a two-part question about the volume expansion of the two different materials here. We have two different objects, a steel drum, and we're told the original volume of that container and the coefficient of linear expansion of that steel drum. The second object is the liquid that has its own coefficient of thermal expansion. But the key difference here is that we're given the volume expansion coefficient for the liquid and the linear coefficient for the steel drum itself. Both will have the same starting temperature and ending temperature, and both have the same starting volume, because it says that the steel drum it physically holds this many gallons at its current size, and that it is filled to the top with the fluid. So, at the beginning, my number is 57.5. This is the amount of gallons that the steel tank holds at this temperature. This is the amount of gasoline that is in the tank at that temperature. They both have the same starting volume. And the issue here is that we need to see if I'm just going to say gasoline because that's my sample material here. What we need to calculate is if the gasoline expands at a faster rate than the steel drum itself does. So the formulas that you will want, this is coefficient of volume expansion. Sorry, this is thermal expansion, specifically volumetric thermal expansion. So this is the primary formula that one would want to use. Delta V divided by V, that's change in volume over original volume equals beta times change in temperature. The question has given you all of the information that you would need just right off the bat to find the change in volume of the gasoline specifically. You have the starting volume of the gasoline, you have the change in temperature of the gasoline, and it gives you specifically coefficient of volume expansion for the gasoline. So whatever your liquid is, it specifically gives you beta for the liquid. And so, that's all the information needed to solve for delta V for that particular question. I'm actually realizing now that I might not be screen sharing my notes. Hang on. A window. There we go. Okay. Hopefully my notes should be visible now. I apologize if they weren't before. I've been motioning at this particular formula. Delta volume equals original volume. Sorry, delta volume over original volume equals beta times delta T. The problem gives you all the information to find specifically delta V for the gasoline. We need to compare that to the delta V of the steel drum. Because if the gasoline grows more than the drum does, gasoline is going to spill out. If the drum grows faster, then there won't be any spilling. Now the question gives coefficient of linear expansion for steel, which is not beta. So instead, you're going to have to, I recommend employing a small shortcut. Whoops. There's a little blurb right here on the slide that I did mention. We have not used it in an in-class example yet, but so I'm going to reiterate it now. Since volume has 3 dimensions and length is only 1, every beta value is equal to 3 times the corresponding alpha value. So you were given the alpha value for steel, and admittedly, the table in the notes that lists alphas and betas does not list the beta for steel. In fact, the same line lists the alpha for steel and the beta for gasoline, if you were to try to find the information you needed on our table. But the table doesn't actually need to list the beta for steel because you have the alpha for steel, and you can just multiply it by 3. So if the alpha for steel is 11 times 10 to the negative 6th, the beta for steel would be 33. No, sorry. That would make sense, but it's an inverse exponent, so I'm going to double check real quick. I don't want to say the wrong thing. Okay, yes. The beta for steel is 33 times 10 to the negative 6th. And regardless, that number doesn't seem to be randomized. So the alpha for steel is 11 times 10 to the negative 6th. The beta for steel would be 33 times 10 to the negative 6th. So that does mean we do have both betas. We do have both starting volumes. We do have both temperature changes. We can figure out the change in volume of each one. And just looking at the numbers in the question, the steel's beta would be the 33 times 10 to the negative 6th. My sample is gasoline. You'll have likely possibly a different fluid, but odds are, just as part of this question, its coefficient of thermal expansion, of volume expansion, is going to be pretty similar to the one that's listed here. Most liquids, if we glance back at the notes real quick, most liquids have a volume expansion coefficient to the order of times 10 to the negative 4th. Everything on this table, on the volume chart here, that is a liquid has a value of times 10 to the negative 4th on it. That's because liquids expand more than solids do when heated most of the time. Liquids are already less dense, their particles are already further apart, and so it's easier for their particles to get even farther apart as they heat up. So the volume expansion coefficient of your liquid is already a bigger number than the volume coefficient for steel. That means that no matter what your mystery fluid is, as long as it's liquid, it's going to expand more than the steel does. So the goal here would be to calculate both delta V's. You want to know the change in volume of the drum, you want to know the change in volume of the liquid. And once you have those two delta V's, you need to compare them, find the difference between them. Say you work it through and you find that the steel drum increases in size by 1 gallon, whereas the volume increases in size, whereas the liquid increases in size by 5 gallons. So 1 gallon growth compared to 5 gallon growth. That means that there's a difference of 4 gallons of gasoline that's going to leak out of the tank, because the tank only grew enough to hold 1 more gallon, but there's 5 more gallons. Same amount of gasoline, it just takes up more space. Does that help with this question? You're welcome. All right. Any other questions or issues at this particular time? All right. So, I'm of two minds about what I want to talk about next, because we've gone through all the Chapter 10 stuff. So, officially, we're done learning it. We've gone over all the material. It's all been covered to where all the formulas needed have been talked about at some point. I'm a little torn whether or not to just start talking about Chapter 11 next, or to give you guys space today to figure out Chapter 10, to finish Chapter 10 stuff so that we can just start completely on 11 tomorrow and not worry about any cross-contamination. I'm a very indecisive person, so I'm currently sitting here trying to make a decision I should have made already. I think... All right. Yeah, how would you... my current plan, the current option that I'm deciding, that I'm going with right now, is... Let's start Chapter 11 tomorrow. If we spend like an hour or so on Chapter 11 tomorrow, we should cover everything that would be needed before the lab on Thursday. And today, then, we can unofficially sort of pause here, and you guys can take a break, work on your Chapter 10 homework, and I'll be in here if you encounter any more issues while working on it. How does that sound? All right. Again, I'll be here if you need me for the next hour and a half or so, and let me know what issues you run into, if any. And we'll start Chapter 11 tomorrow. Do be here for that.